This is the me588 interim presentation for Team 4. This team is comprised of Adrian Buffis, Peter Brushnack, Jonathan May, Joseph Taylor, and Charlie Zhang. The product we've chosen to describe is a latch clamp, as pictured here. The latch clamp is made of 11 parts, primarily made of stainless steel. On the right can be seen the product with labeled parts. The main function of this assembly is to hold two objects together, and it can be found in products such as barn doors, hatches, mold closures, as well as other situations that call for a latch mechanism. The product is controlled primarily by the lever, which, when pulled down, locks the U-bar in place with the hook. Both ground plates essentially ground the mechanism and provide a fixed point at which the lever can lock into the hook. There are several positions of the product, the lock position as well as the release position once the tension is released with the lever moved upwards.
As mentioned previously, our latch clamp is made up of 11 different parts when fasteners are excluded, and you can see all 11 on the excluded view on the right. All individual parts except the lever grip are made of steel for strength and rigidity. The lever grip is made of rubber, so the lever itself is easier for the user to grip, hold, and control. The bill of materials, or BOM, is shown on the left and lists the part name, quantity found in the latch clamp, material the part is made from, and the associated manufacturing processes. Almost all parts are either stamped or forged in our latch clamp.
The first key characteristic is the X component of distance between the outside of the latch hook surface and the inside of the U-bar surface in the locked position, depicted in the image at the bottom right of the screen. This KC will measure the horizontal distance between the outside surface of the latch hook and the inside surface of the U-bar while the clamp is in the locked position. This KC is particularly important because it allows the latching process to occur. If this distance is unconstrained, interference may occur between the U-bar and latch hook while attempting to secure the latch. If KC1 is greater than its nominal value, there can potentially be interference between the U-bar and latch hook on the left-hand side that would prevent successful latching. On the other hand, if KC1 is less than its nominal value, there will not be enough clearance between the U-bar and latch hook on the right-hand side for successful latching. It is important, therefore, that KC1 is at its nominal value to ensure adequate clearance between the U-bar and latch hook on both sides.
The second key characteristic will measure the vertical distance between the front of the U-bar cylindrical axis and the surface of the base plate arm for the purpose of vertical clearance of constituent parts. The U-bar rests parallel to the base plate in the locked position, so it needs to be elevated a minimum distance above the base plate to avoid interference with accessory parts mounted to the base plate arm. The figure illustrates the relationship between this KC and the latch clamp function. Namely, if KC2 deviates from its nominal value and does not achieve U-bar parallelism for bar tension, the device will not be adequately locked, undermining the product function. Additionally, if KC2 is found to be much smaller than its nominal value, then the fasteners attaching the fulcrum bracket to the base plate arm will interfere with the connecting rod. This in turn will prevent the U-bar from correctly attaching to the latch hook.
Here are the liaison diagrams for both KC1 and KC2. The liaisons are marked in red and shown with doubled lines. KC1 is the X distance KC between the U-bar and the latch hook. In order to connect these two nodes, there's a chain of liaisons that pass through the connecting rod, the left and right lever arms, the lever pin, the left and right fulcrum brackets, the arm base plate, and the hook base plate. KC2 is a Y distance KC between the U-bar and the arm base plate. In order to connect these two nodes, there's a chain of liaisons that pass through the connecting rod, the left and right lever arms, lever pin, and the left and right fulcrum brackets. Here are the delivery chain diagrams for both of our KCs. Each delivery chain is shown in a different color: red, blue, green, and orange. Both KC1 and KC2 pass through the lever arm and fulcrum bracket, each of which has a left and right set. A permutation of these two choices results in a total of 4 delivery chains for both KCs. This means that both of them are over-constrained. Additionally, as the delivery chains of both KCs share multiple liaisons, there's a chance for KC conflict.